Over the years, scientists have finely tuned techniques, invented many new ones, and have made much progress in discovering alien worlds. Now, scientists can even determine what some exoplanets are made out of. In order to do that, scientists obtain what is known as a planetary transmission spectrum. It is acquired using light that streams through its atmosphere. If the planet has no atmosphere, it will block the same amount of light at all wavelengths. If it does, gases within will absorb additional light. The two numbers are then divided and you get the planet's atmospheric transmission spectrum. When light interacts with atoms and molecules in the exoplanet's atmosphere, it absorbs certain wavelengths on the spectrum. These wavelengths are indicative of certain elements on the spectrum. Whenever light is observed from an object, that light can be measured to determine what has been filtered out. For example, when scientists observe a distant planet, they can detect the starlight that is passing through its atmosphere. Different elements absorb light, rather than allowing it to pass through, but they only absorb certain parts of the light spectrum. This generates a light signature. Using an instrument called a spectrometer, astronomers can measure the light they are detecting through the atmosphere, and then spread out that spectrum, which will end up looking like a barcode. The missing chunks of the light spectrum tell us precisely what elements are present in the atmosphere. Scientists have measured the light absorption of every known element for centuries and can use that as a reference scale to decipher the barcode of light. If we were to look at a light spectrum coming from Earth, the barcode would be missing the frequencies that correlate to nitrogen, oxygen, and argon, as these elements compose Earth's atmosphere. These light spectrum readings give astronomers and scientists the access to the fingerprints of the universe, and our ability to read and understand these measurements is only getting better. In fact, certain spectrometers don't even read visible light. Light that is outside the visible spectrum, such as infrared, ultraviolet, X-ray and gamma rays. These measurements follow the same idea. However, they can tell us a great deal about the elemental composition of objects even from across the universe. How do scientists determine the composition of a planet? We know what the composition and size of the Earth is, specifically its density, so scientists can apply that same information in comparison to other planets. If scientists find an Earth-sized planet that has the same density, they can then assume that they are made of similar components, silicate rock surrounding an iron and nickel core. If a star is far more massive but less dense, then it is more likely to be a gas giant, for example Jupiter, Saturn and Uranus. Such planets are composed of lighter elements like hydrogen and helium surrounding a rocky or molten metal core. Calculating the density of a planet is another tricky question. However, because we need to know the mass and volume of the planet, based on what we have learned about orbits and the Newtonian laws of physics, scientists can calculate the mass of a planet based on the effect it has on its parent star. As a planet orbits a star, there is a minuscule pull on the star caused by the mass of the planet's movement. This wobble is because the planet pulls on the star, slightly shifting its velocity. These changes in velocity can tell us the mass of the planetary object with extreme accuracy. Based on our knowledge on the redshift and blueshift phenomena, commonly known as the Doppler effect, calculating the volume of a star is a slightly less exact measurement. By watching eclipses or a moon passing in front of a planet, scientists can detect the dimming of light caused by that crossing. When a planet passes in front of a star, it occludes a certain portion of the stellar surface, which can be measured, and a diameter can be established. Once a diameter is calculated and the shape of a sphere is assumed, the volume can be somewhat accurately measured. With volume and mass in hand, density can then be calculated, giving scientists an idea of what type of a planet it is, either rocky, molten, Earth-like, gas giant, or something else entirely. Researchers can then make educated guesses about the type of element that would be found on the surface based on this measurement. Has your curiosity been fulfilled? If so, leave a comment down below, and if you're curious about more, then check out our social media for daily facts. Also, don't forget to subscribe for more educational content and hit that bell icon to stay up to date with future uploads.